dietary carotenoid intake is associated with a younger biological age, which is what we'll see here. So in this study, they looked at the biological age clock that I published over and over on this channel, PhenoAge. And then they looked at its association with dietary intake of total carotenes, which included alpha and beta carotene, but also beta-cryptoxanthin, lycopene, and lutein plus zeaxanthin. In terms of what was significant, we put up a red line at 1, at a PhenoAge of 1, and then where the shaded blue line is either completely above 1 or completely below 1, we have a significant association. What we can see for each of these dietary carotenoid intake variables is that relatively low levels or relatively low intakes were significantly associated with an older PhenoAge, moving in the wrong direction. And on the other hand, relatively high intakes were associated with a younger PhenoAge. And I've included the amounts, the maximal amounts, that for each of these carotenoids that the range went up to. Now, there is one exception to that, beta-cryptoxanthin. With beta-cryptoxanthin, there's a sweet spot where going too low may be bad for PhenoAge, but then you can see that although the data moves in the wrong direction at higher intakes, it just loses significance in terms of a younger biological age. So there may be a sweet spot for some beta-cryptoxanthin being associated with a lower biological age relative to higher. Now, to compare this against my intake, we can see that it's in the same ballpark. And it's studies like this that are one reason why. But studies like this, for me, are just a guide. This suggests to me that having relatively high carotenoids should be a part of one's diet if the goal is to slow or minimize changes to biological age. But because I have so many blood tests, I'm able to see what my own correlations say and then come up with my own personalized data for where each of these measures should be. Now, is that actually causation? I don't know, but it may be a part of the story.